These are the kind of, I sent some of them. These are the kind of questions that they have on the example questions.
Got it.
Okay, so this one. What does reciprocal mean again? I forgot what.
The flip of the number. So like if your number was 1/2, the reciprocal is 2/1.
So it has to be the opposite of the number?
No, the flip. Think of it as flip. Like 7/8 becomes 8/7. That's the reciprocal. So let me just quickly explain this.
What's the reciprocal of the number?
Well, this one's more actually like a how do I want to say it? It's a test taking strategy. So find a positive number which when increased by 11. So you actually want to make a table here where you increase each of these numbers by 11. 26, 15, 22, and 18. Okay. And then the next thing you need is the reciprocal of the original number. So the reciprocal of the original number is 1/15. 15/1 becomes 1/15. That's the whole, like, take the number and switch the top and the bottom. And then 4 becomes 1/4. 11 becomes 1/11. And 7 becomes 1/7. Okay. Now, the next thing is they want you to multiply each of these by 60. And I probably lost
it's like all those 1/4, 1/15.
Yes, all
multiplied by 60.
Yes, and there's only two that actually work out reasonable, which is the first two, because 1/15 times 60 is really 60 divided by 15, which is 4. And then 60 divided by 4 is 15. So which of these, well, actually none of the, I'm sorry, a positive number when increased by 11, that's this number. See how this 15 equals this 15? That's what they're looking for here. Again, I just grabbed this. Maybe this is not the right type of question for us to be working on, but something to think about. Let me make sure these have uploaded. They have, or they are in the process of uploading, and we can switch to working on some of those from that pages you sent. All right, they did upload. And you're welcome to send more. Yeah, you're welcome to send over as many as you want, whenever you want. It's not gonna bother me. Okay, yeah, these are good questions. These are good questions for us to think about and look at in our lesson today here. So let me snip that in. Oh, it's just one of those, everything's just harder than it needs to be right now. All right, which of the following expressions is equal to 6 minus 4 times x plus 3 in parentheses? And we did do some problems like this where you have to decide, are you going to treat this as -4 outside here or subtracting 4 times each of these? And I don't really remember what we discussed. Did you remember thinking of it as -4 or just the 4?
-4.
Okay, so this is -4 times x plus -4 times 3. And then you're just bringing the 6 down for the moment. What is -4 times x?
-4x.
-4x. 6 plus that, and then -4 times 3.
-12.
-12. Okay. Are there any like terms here? Are there any things that you can combine?
The 6 and the 12.
6 and the -12. Good. What does that become?
-6.
Okay. -4x minus 6. What is your correct answer here?
Like to the question itself, or
Yes,
like if I got
yes.
the same thing? Oh,
Yeah, yeah, which one? A, B, C, or D?
oh, it would be D.
Be D. Good. Okay. Do you want me to give you one like this?
Yeah.
Okay. So kind of same thing. Which of the following here? 4 minus 3 times x minus 2. And let me give you some answer choices here. Actually, that's not necessary. Why don't you just work through this? We can do that another time. But yeah, why don't you try working through this here, like we did in the last one? And let me just scroll up in case you want to look at that previous problem that we did.
So it'd be 4 and then negative 3x. And then would it be positive 6 because they're both negative? Or
Yes.
no? Okay. Then
Yes.
plus 6.
Good.
And then you could do the 4 and the 6. So it would be 10. So it would be negative 3x plus 10.
Good. Excellent. All right, let's look at question 2. All right, question 2. If Chris makes D dollars and Heidi makes $75 less than 3 times Chris's wage, what does Heidi make in terms of D? Okay. Now, there's a couple of ways to do this. The kind of the way that they want you to do this is to write the equation. But because it's multiple choice, you can actually use a strategy where you put a value in for D. That might be easier, but you then have to test it in each of the answers. So I guess my question to you or thought for you would be, would you prefer to write the equation or use more of a guess and check approach?
Is it something that you have to figure out the actual amount on, or are you just like, is it like how you would figure it out? All the answers look like an equation, not
Right.
like.
Right. So then there's, to answer your question, like you do have to make a guess for D and then try it in each of these and see if it actually works out. The kind of in-between approach is to look for something in the problem, like maybe the 3 times, and see if that helps you reduce the answers. Like, do you see a 3 times in any of the answers down here?
C and D both have multiplication in them.
Yes, yes. So that's kind of the in-between. That means it's either C or D. And then what's the difference between C and D?
C has 75, so it would be 3 times whatever she makes, and then minus 75 because she makes 75 less, unless it's a
Yes.
trick question and you have to.
It's not a trick question.
Okay.
I like that though. You're already kind of on guard here. It is just the 75. Yes. Okay. Now here's what I meant by you could try a number. You got to be careful though. Like you can't pick 0, you can't pick 1 typically. But let's say Chris makes $100. So Heidi makes $75 less than 3 times Chris's wage. So 3 times 100 is 300. And then when you subtract 75, that's 225. So now what you have to do is go to each of these and try 100 in for D. 100 plus 75, 100 minus 225, 3 times 100 minus 75, 3 times 100 minus 225. That's a little riskier, but it does work. But you can see that it will still be letter C.
Yeah. Because that's the only one that has like the
Yes.
amounts.
All right. Now I'm going to, I do this from time to time. I'm going to skip 3 because we haven't really talked much about scientific notation, and we can, but let's not do it right this second.
I remember a bit of scientific notation. I could probably just read over it. That one is like the one where you would like count the zeros and like figure out where to put the
I like that. Did you say busy rows?
what? The
Did you?
zeros?
Oh, the zeros. Okay. I thought I heard something different. Yes, you count the zeros. I thought I heard something
They're
different.
also like busy rows.
Busy
Rows
rows.
of zeros.
Yes, busy rows. I like it. All right, let's look at a new problem here. Number 4. If there are 4x identical schools in a region, and each school has 3y classrooms, each with 7x desks, how many desks are there in the region? All right. This again can be done 2 ways. It can be done where you sort of pick a number, pick a number, pick a number, and see if it works out. Or you can try to use the equation, okay? Or some combination thereof. Like maybe it's you say, okay, well, I can't do all that, but I can do a little bit of each. So in this case, oh, good.
I mean, none of the, because I'm assuming you would like combine some of the numbers.
Yeah, I'm looking at it like this way. There's a classrooms, right? There's some number of classrooms inside a school or schools, right? Like they're kind of nested inside of each other. Like there's these four rectangles are also in this school. No, okay, that's not making much sense. Let's try it differently. Let's say, and we got to be careful with numbers here. Let's say that each classroom has X equals 5 desks. Okay, so how many desks would be in each classroom?
7.
7 times X. 35 desks. Now let's say a school has Y equals 4 classrooms, or Y equals 4. Let's keep it simple there. How many then classrooms does it have?
3.
3Y, 3 times 12. 3 times 12 or 36. I'm sorry, 3 times 4. Just let me start over there, man. 3 times 4 or 12 classrooms. How many desks are in each classroom?
$35.
35. So like first room is 35, second room is 35, and so on. So now you would multiply those together, 12 times 35, and you get whatever you get. In this case, it's 420, believe it or not. And then there are 4 times the schools. So if there were 4 schools, what would you do to this number here? Like this is for
Would you
one school.
multiply that by 4?
Yes. Okay. So here's what I want you to think about before you go much further. When you look at the 4 answers, these 2 have addition, these 2 have multiplication. Which 2 can we eliminate?
The first 2.
Yeah. So you can always do something to kind of reduce it. Okay. Now, how can we come up with the correct answer here? Because we can't just use the numbers. What is the difference between C and D?
Where the exponent is.
Yes. Now, when you look at what we've done, 4x times 3y times 7x, which will have the greater exponent, x or the y in this case?
X, so it would
X.
be D, but I don't really get it. I mean, I get how to get rid of the first 2 choices, but
Right. Well, it's a product. This is a product of these 3 numbers, and that's what we were doing before. We took
oh, okay.
this 7x times the 3y, and then we were going to then multiply by the 4x. But I mean, at some point, I wanted you to see that you can kind of use some test taking strategies to reduce this, and then you just need to know the difference between the two answers. Okay, ready to move on?
Mhm.
All right. All right, which of the following is equivalent to x squared minus 25? This is one of the types of factoring that you and I did at some point. Meaning that you have seen this before. There's not like some mystery of what this actually is. Do you remember at all any of the types of factoring, or maybe this one?
I had them written down somewhere on the notebook I was using, but which kind is this?
This is difference of squares, which may or may not be helpful, right? But maybe
The one that
there's
had to do with pi?
it has to do with the 25.
But the square of it?
So let me give you an example. Let's say it was x squared minus 81. This becomes x minus 9, x plus 9. How is the 9 related to the 81?
Yeah, because it's just the square of it.
Square root of it. Yeah. So it's got all these have the same form. Okay. Now let's just say you didn't know what I said on the right, or you've forgotten. Again, you can kind of use the answers here. Like you could actually multiply all the answers together to see which one is correct. But that is a lot of work. You really want to know each of the types of factoring like we had talked about when you're working
So
through
it would,
this.
this one would be easy because it would just be C, because that's the,
Yes, yes. So the classic mistake though is to choose B thinking you just square and square, which is not correct.
yeah, you have to do the positive and the negative. Does it matter which order it's in?
Nope, could be
Okay.
neither order. Good question. All right, anything before we move on? Other questions on that?
No, I think the difference of squares is probably, at least when it's like a simple one like this, it's pretty easy as long as it's a number you can get to the square root to pretty fast, like 25 or 81.
Yeah, that does
Maybe.
make a ton of a difference. Yeah. Okay. So we saw a problem like this a couple questions ago. You know, it had a 9x or it had a 4y and an x and some other stuff. But this one has some different language. It says if Tom has 9x baseball cards, Adam has 13 more. What math operation is more typically associated with?
Addition.
Addition. And notice all the answers have addition in it. And Dave has 2y baseball cards. Together they would have how many cards? Okay. So let's go down the list here. Tom and then Adam. So let's start with Tom. How many cards does Tom have?
9.
9x.
Oh, yeah.
Okay, now for the next one here, be careful how you answer it. It is not 13. It is not just 13. Adam has 13 more than Tom.
So that would be plus 13.
9x plus 13. Because it's all the ones that Tom has and 13.
Would it be A or would that be too easy?
No, we're not. No, it's definitely not A.
Okay.
A is the most common wrong answer. So we got to keep going. We got to get Dave. How many cards does Dave have?
2y.
2y. And what are we looking for? What does the word together mean? The total. Think of together as the total. So adding all of these up. You get your bill at the restaurant, you know, burger and fries, and a salad. And you're adding it up over here. Now, one of the things you might notice when you look at the answers, this is a great question for what is the same and what is different. Like 3 of them have 2y in it, and 3 of them have 13 in it. So you might be able to eliminate some answers because of that.
So it'd be D.
It is D, yeah. All right. See, these are good questions, and these are not really the hard algebra. They're more of just the sort of the like, okay, we're gonna give you a scenario and see if you know how to like combine like terms, because that's really what this problem is. Okay, this is a new question. I actually have not seen something like this in a while. The figure below is a multiplication box. Each number represents the horizontal number multiplied by the vertical number. For example, the 9 in the lower right corner equals 3, this 3 up here, multiplied by this 3 down here. Similarly, 5, you can see 5 is 5 times 1. They're asking you to find these other ones here, okay? Maybe. Now, this is where you got to be careful about what you actually do with your time. So what you don't want to do is fill all of them in. You want to wait and see what you're actually trying to figure out.
But did I not get the whole question on that one? Because there's
Yeah.
an answer,
Right.
so answer choices for it.
Yeah, but
Oh,
what I was
okay,
trying,
never mind. I
to say
thought
is
it
like if you start trying to figure out what goes here, you might waste time that you don't need to. So be careful here. Okay. So they want you to find A times B. A times B. You've got to identify those in there. There's A and there's B. Okay. Can we find the value of B? What does B equal?
15.
15. It's 3 times 5, that's 15. Do we know the value of A?
A might be a little trickier because it's C and Y, but then,
Okay, so can you find C?
yeah, I think so. 2? No, wait. 4?
There's 4. So A is 4 times Y. You take the whatever that is times whatever that is. We don't know enough to find it. Say that again.
Do I have to find Y or no? Because there's a Y in the answer choices.
That's good. That's really good that you see that. No, you do not find Y, and it's because it's in the answer choices. But you want A times B. You want the product of these. What would that be?
Okay, so it would be B.
It would be B. Good. Very good. So 15 times 4Y is 60Y. Good. All right, so let's do the next problem here. All right, and you see, and we found that C is 4. That might be useful. Let's take a look at number 8. A minus D. So do we know anything about A?
No.
What did we figure out?
Yes. Oh, wait, okay.
A is 4Y. Now, D is right here. What is the value of D?
I'm not sure because we didn't figure out Y.
But we didn't figure out Y for A either. How did we write it?
So would it just be? I'm
Keep
not
going.
sure.
Yes, yeah. Come on, you're almost there. A is 4 times Y. D is right below it.
So it would be DY.
What is this number here?
3
Times
Y.
Okay, so I'm trying to get you to see here is that to get A, you cross these two. 4 times Y. And then similarly, to find D, you can cross these two. 3Y.
So it would just be D?
Yes. So now, one of the things you could have noticed right after you wrote the Y is that there's only one answer that had Y in it. And that would have been enough to say, yep, that's my answer.
Okay.
So there are a lot of those sort of little test taking strategy things in here that you can leverage. Okay, well, I think that takes care of the 2 pages you sent over. I don't know if you want to send over a couple more or have
Yeah,
me
there's
go back. I mean, I like these. I think these are good to work on, but totally up to you.
there's at least 3 more pages, I think. It's like 4 pages, I think, for each of the like end of section practice tests, which is nice because it's a decent amount of questions.
There it is. All right, let me
Let me
upload
know if
that.
any of these are too small or unreadable, any of the questions. I'm trying to see if I can get them on the least amount of.
The quality is great. You know, the iPhone has the best camera, at any time, it seems like.
Yeah, that's one thing it'll always have over on Android. is the
Yes.
camera quality.
Yeah. I don't see them doing ads though of, students taking pictures of their homework and test prep books, unfortunately. So, all right. Yep. Got them. Let's take a look here at number 9. Just comparing these, I think this is okay. So nine is quite a bit of work to do.
And
Wait, am I looking at the right one?
we've done this before though. This is
Yes.
just been a second since done the multiplication.
It's a lot like I think the first or second one we did. Let me snip it in here. All right, we're all set up. Okay, it says to multiply 7c squared times a squared times 5b times 7c squared. And again, I'll just point you to the answers. Like, look at some of the answers, see what's similar, see what's different. Like I noticed right away that the last one, there's 3 49s and a 14. That might tell you something. Like when you look ahead to 7 times 7, what is 7 times 7?
14. So that one has 14C too.
7
And
times
those two.
7 times 7 is 49.
Oh, never mind. I thought you were saying plus. I was looking at the addition.
Sorry, yeah, you're multiplying. So yeah, if that helps, I'd recommend doing it. But you do, for this problem, you do have to actually sit here and multiply each of these. 7c squared times a squared, 7c squared times 5b, 7c squared times 7c squared. The main thing when the bases are the same, like when you have a c times a c, the exponent becomes, you're adding the exponent. You would add the 2's.
That's if they have, it's the same letter.
Yeah, if they're not the same letter, they just remain as is.
So the first one would be like 7C2A2
So
or
generally,
7AC2.
yeah, generally you do it in alphabetical order.
Oh, okay.
Of course,
All right. So 7A2C2. C squared, C squared, and then 7C squared times 5B is 35 B C squared.
Good. And this is where it's good to look at the answers because you actually have enough to decide what the answer is.
Okay, so it's A?
Yes.
Okay.
Okay, and really there's a strategy to look at the answers as you go, to not just, keep working them out. Time is working against you. Do the best you can to minimize that wherever possible. All right. Little League Pie sale fundraiser. All right, Little League Pie sales fundraiser generated $900 in revenue. Okay, so revenue is price times however many you sold. So they're telling you the revenue. They're telling you that that's 900. That's R. They're saying they sold 6x pies. Is that the price or is that the quantity?
Quantity?
As the quantity. So you have to figure out the price. You have to figure out P in this problem. Now you can use the answers. Okay, that's totally okay. Like you could sit there and say, okay, is P 10? Is 10 times 6x 900?
No?
Nope, that one's out. How about
Is it gonna be C or D because they have X's in them?
yes? Now that's the question: is which one is it? Which one causes it to go away? So you can just try them. Like, is it x over 150 times 6x? Does that cause the x to go away?
How would I do that? How would I multiply that?
So let me write the other one, and maybe something will jump out at you before I answer that. Do you see anything on the one on the bottom about with cancellations? Do you see on the bottom there's an x in the top and the bottom?
Mm-hmm.
So when it's on the top and the bottom, they cancel. But when they're both on the top, they combine.
So it'd be D?
Yes. I like your thinking though, where you kind of were tuned into the answers with X in it. It's really good. So quickly here, let me quickly give you, this kind of getting into some problems where you probably need a little bit of explanation here. Let's say it's X over X, or actually, let me do it differently. Sorry. Start with something else. What is 3 divided by 3?
1?
1. X divided by X, what does that become?
1?
It is 1. So if they're the same on the top and bottom, they cancel. How about X plus 5 over X plus 5? What does that equal?
1?
1. If they're the same on the top and the bottom, it becomes 1. Now, what if it's X minus 1 over X plus 1? Are these the same on the top and the bottom?
I don't know. I mean, no, because of the sign, but
That's right. Yeah. Whereas the previous ones were, but because the sign is different, they are not the same. Okay, good. So we have enough here to look at number 11 and try to answer it here. All right. Simplify the expression. So this is a more complicated version of what we were doing, but you're looking for things that are the same on the top and the bottom. Does anything jump out to you as being the same on the top and the bottom?
there's an A minus 4.
Okay. So on the top, there's really like 2 of them. So if we cancel that 2, that leaves 1 remaining. Is that, if I cross out that 2, that means this one still remains because there were 2 and now they're just 1.
Okay.
So one of the things you should notice now is like your answer is going to have an A minus 4 in it. Which answers have an A minus 4 in it?
A and B?
And what's the difference between A and B?
The which signs on the top and bottom?
So is A minus 4 on the top or the bottom?
The top?
It's on the top, and there's nothing in here to make it go to the bottom. So the answer is A, but let's keep going on this. 6B, do you see any B's over here?
3B?
What about this 2 on the outside? What can it do?
It turns it into a 6B?
And then they cancel. So what would be the correct answer?
So it'd be A minus 4 over A plus 4.
You got it. Let me give you another one like this. That's okay.
Okay.
Okay, I want you to just simplify this as much as you can, please.
So this one there would be 1x plus 2 on the bottom, because it would cancel except for the one that was left. And then the other one, you could multiply the first one into 20a, and the same thing with the second one, so they would both cancel out. So it would just be, would it just end up being x plus 2 or no? Is there something on the top still? Would it just be 1a? Or just 1? Hello?
Sorry, I'm so sorry. Muted
I'm
myself.
sorry.
I was just
I thought it
readjusting my
was
chair.
my connection.
No, so there's always a 1 in the numerator. There's always a 1 in the denominator if it needs to be written. Is that okay?
But I would need to put a 1 on the bottom.
Just the top, just the top. The
Okay.
1 on, like when you divide by 1, that's okay.
Okay.
All right, let's look at number 12. All right, E buys X ounces of chicken for each of her guests at a dinner party. There are 8 Y people coming and chicken is Z dollars a pound. How much will the total amount of chicken cost in dollars? Hint, hint. So there are 16 ounces in 1 pound. All right, we've done a couple like this. I know that these are really difficult because they're variables, there's no numbers. I guess first thought is, are you multiplying or adding in this scenario?
Multiply?
You are multiplying. So at a minimum, you could multiply X times 8Y times Z, okay? And is that answer there?
Yeah.
It is. But what did we not use?
There's 16. Would it be B because it's 16?
Well, we've got to somehow account for the ounces and pounds, okay? Because your answer is in terms of ounces, and they want it in terms of the price in terms of pounds. So how do you convert? And this is sort of a question: is how do you convert ounces to pounds? Okay, and let's just do a simple example. Let's say I give you 32 ounces. How many pounds is that?
I don't know.
So there's 16 ounces in 1 pound. So 16 ounces is 1 pound. 32 ounces is 2 pounds. You're dividing by 16. right? 48 ounces would be 3 pounds. So to go from ounces to pounds, you will divide by 16. So we have to take your answer and divide it by 16.
It's not an option on there though.
I agree. We have to do a little bit of simplifying. So let's take a look here. The numerator is 8xyz over 16. Is there anything that you see that cancels?
No.
How about the 8 and 16? Does 8 go into 16?
Yeah, but they're not the same number.
That's okay. So remember how we were doing reducing fractions a long time ago? If the same number goes into the top and the bottom, you can reduce it that way. All right, so 8 over 16, if you divide both of them by 8, it reduces to 1 over 2.
So it would be C.
It would be C, yes. But the key here, and this is, you did really good on this one, is you knew to multiply. So that got you to A. You had to account for the 16. You just had to figure out whether it was multiplying or dividing it. And if you'd multiply the numerator by 16, none of those would have matched your answers. So you might have thought to then divide, and then it would be there. But you're really good. Like, I'm hearing really good stuff here, like things to be really excited about in terms of getting through this test. Okay, new question here. I think these are going to be good for you. Number 13. All right, it says, what is the value of the expression 6 times x minus y minus 8x when x equals minus 2 and y equals 5? So your thought process should be, I've got to take each of these numbers and put it in for x, put it in for y, and then put this number in for x. And the only way you can make a mistake is with sign errors. Okay, so the best thing is just go really slow here. X is minus 2 minus y minus 8 times negative 2. Order of operations. What do you do first? Do you...
-2 minus 5.
Good. What does that become?
-7.
Yes. Okay, and here's what I see now. I see multiplication. There's really multiplication between these two. This is subtraction, and this is more multiplication. What comes next?
So do the multiplication. It'd be
Yes.
6 times -7, which would be 42.
Negative 42. Good. And then do 8 times negative 2.
Would it be -8 times -2?
Sure. If you prefer that, I like that. Then this becomes plus.
Oh, is that bad or is that bad?
No, I like it. No, it's good. It's good.
Okay, I was reading it. I tend to read it that way instead of that minus that, because then
I think that's a good approach.
that would be plus 16.
Good. So what is your final answer?
So -42 plus 16 would be
Did you give me an answer? I'm sorry, I didn't hear if you did.
B.
Yes,
I had to use my calculator for
good.
the,
Yeah, and I would recommend to keep using your calculator for a while. The more you do this, the more you'll get comfortable with the calculations. Or try and do it by